Hey everyone, Mr. Fransky here. Today we're going to get into 2.4. We're going to talk about just a little intro here to long division of polynomials. And this is similar to long division with numbers if you've ever done it. We're just adding variables in along with it. So today students will be able to divide two polynomials using long division. Let's try it. So vocabulary: dividend, divisor, quotient, remainder. Those are pieces of the division problem that we're going to be using. Probably words that you've heard before, but maybe don't remember everything about. So let's take a look. So a tale of two problems. It was the best of times, it was the worst of times, right? Well, let's see. So 3587 divided by 32, and we're going to relate that to 3587 divided by 3x plus 2. And it's really the same problem, same process, just a little bit different because we have the variables there. So if you've never done long division before, the way you do this is you say 32 is dividing into 3,587. And really where we start is we say, how many times does 32 fit into 3? Well, I can't fit 32 into 3, so go to the next digit. How many times does 32 fit into 35? Well, it fits in there one time. So really what you're doing there is you're saying that 32 fits into 3,500 100 times, right? The 1 here represents 100, but we don't say that. Like, we're just using shorthand here. So then what we do is we say, okay, we take that away. So you subtract 32. 5 minus 2 is 3, and we still have an 87 left. So what's happening here is I took away 3,200, right? 3,200 is now gone because that 100 times 32 adds into that. So now how many times does 32 go into 3? It doesn't work. 32 into 38, though, one time. So 1 times 32, really 320, right? Subtract that. 8 minus 2 is 67. Now I can fit 2 of those 32s into 67. 2 times 32 is 64. Leaves me with a remainder of 3. So how you write this is 3587 divided by 32 is 32 with a remainder of 3 that are still trying to divide into 32. Or 32 is still trying to divide into 3. So 32 and 3/32 would be the answer to this guy. How you often also see this written is if you multiply both sides by 32, you can write this in what's called factored form. So we would have 3587 is equal to, what am I looking at here? Oh, this is 112. I knew I had something wrong. 112 is my answer, right? So 32 times 112. So 32 times 112 gets me almost to 3587, but I'm short 3. Excuse me. So I'm short 3 at the end there. So 32 times 112 plus 3 is called factored form. And this guy up here is called fraction form. Fraction form is where you still have the fraction on the left, and then we have 3/32 on the right. So with variables, really the same process. It's just we have some x's in there. So I do 3x plus 2 into 3x cubed plus 5x squared plus 8x plus 7. So I look at 3x and I say, how many times does 3x go into 3x cubed? So really I'm ignoring the 2 for now. I'm just saying, what do I have to multiply 3x by to get 3x cubed? So 3x times something equals 3x cubed. Well, I need to multiply 3x by x squared. So I'm going to put an x squared up on top here. Yep, so an x squared up on top of the 5x squared just to keep myself lined up. So that represents the 1 that's right here, right? Now we multiply by the entire thing, just like we multiplied 1 by 32 over here. So x squared times 3x plus 2 is 3x cubed. X squared times 2 is 2x squared. Now we subtract it. Parentheses are important, I think, because we're subtracting both. 3x cubed minus 3x cubed, those are gone. 5x squared minus 2x squared is 3x squared. Now what do I need to multiply 3x by to get rid of that 3x squared? Looks like another x. So we have an x on top of the 8x this time to keep it lined up. X times 3x plus 2 is 3x squared plus 2x. And I should have brought my 8x and my 7 down, just like we did over here for 387. Now we subtract. 3x squared minus 3x squared, those go away. 8x minus 2x is 6x. Now 3x times 2 is 6x, so 2 times 3x is 6x plus 4. And now we subtract. 7 comes down again. So 6x minus 6x cancels, and 7 minus 4 is 3. So what I've just shown is that this is equal to my quotient. Quotient is my answer, right? X squared plus x plus 2. And that remainder is 3, which is still trying to get a piece of 3x plus 2. So there's my fraction form. Factored form, if we multiply the entire thing by 3x plus 2, we would have 3x cubed plus 5x squared plus 8x plus 7 is equal to x squared plus x plus 2 times 3x plus 2 plus 3. There's a constant at the end that we need to make up for the 7 at the end, because 2 times 2 is 4. We need that 3 to make the 7. You can kind of see why it's called factored form now, right? Because it looks like we have factors. So this process takes some practice. You can watch this a few times if you need to, but let's try a couple different examples. There's another one. So we're putting, this time, a quadratic into a quartic. So we have 2x squared plus x plus 1 into 2x to the 4th minus x cubed. Now I'm going to add a plus 0x squared and a plus 0x in here, just to keep things organized. Because now we're going to have a place to put our answer on the top. So I should have named these things a little while ago. The guy on the top here is called the dividend. Guy at the bottom is called the divisor. The answer you get is called your quotient. So that goes up on the top. Quotient. Okay, so just a little bit of division vocab there. All right, so let's see here. 2x squared needs to be multiplied by what to make 2x to the 4th? I think we need to multiply by x squared. The reason we do that is because now we multiply by the entire thing. That should cancel out our first term. X squared times 2x squared is 2x to the 4th. X squared times x is a positive x cubed. And x squared times 1 is a positive x squared. Now we subtract all those. 2x to the 4th minus 2x to the 4th, they go away. Negative x cubed minus another x cubed is a negative 2x cubed. 0 minus 1x squared is a negative x squared. And then we have plus 0x minus 2 just come down because they're subtracting nothing. 2x squared needs to be multiplied by a negative x to make the negative 2x cubed happen. So we have negative 2x cubed. Let's see, minus x squared. And then minus x. Subtract again. So negative 2x cubed minus negative 2x cubed, those cancel. Negative x squared minus negative x squared, those cancel as well. 0 minus a negative x is a positive x minus 2. Now, by the time you get down here, the degree is less than the divisor. So we're done. On the last one, we had to go till we got to a constant because our degree here was just 1. We had a linear divisor, so we had to go all the way till we got to a constant. This time, I can't multiply 2x squared by anything to get x, right? You'd have to divide, and we don't want to do that, right? So our answer here, this guy is equal to our quotient, x squared plus minus x. And then the remainder is x minus 2, and that's still trying to divide into 2x squared plus x plus 1. That's our fraction form. Factored form, 2x to the 4th minus x cubed minus 2 is 2x squared plus x plus 1 times x squared minus x plus our remainder, which is x minus 2. Awesome. All right, I think I got one more if you want to try it. If you want to pause the video and give it a shot, not a bad idea. All right, let's see how you did. So x minus 3 into 2x cubed minus 3x squared minus 5x minus 12. So x into 2x cubed, we need a 2x squared there. So put 2x squared up top, multiply down. 2x cubed minus 6x squared. Those cancel. Negative 3 minus a negative 6. That's negative 3 plus 6 will give me a positive 3x squared because I was negative 3 going positive 6. Minus 5x minus 12 comes down. X into 3x squared is a positive 3x. Multiply down 3x squared minus 9x. Subtract that. 3x squareds cancel. Negative 5 minus a negative 9, that's negative 5 plus 9, gives me a positive 4x minus 12. And now x into 4x, we have plus 4 at the end. So we have 4x. And then 4 times negative 3 is 8 minus 12. That gives us a remainder of 0. This is kind of cool. So what that means, if we write this in factored form, 2x cubed minus 3x squared minus 5x minus 12 is equal to x minus 3 times 2x squared minus 3x plus 4. Now this is special because the remainder was 0, so we actually found a perfect factor for this. And we're going to talk more about how to do problems like this when we talk about factor theorem. All right, that's what I've got for you guys. Hopefully this wasn't too bad. See you in the next video. Love you guys. Have a great day.